This is lecture 1 of network analysis and synthesis, and we are going to talk about basic laws about networks. We are assuming that you all know what is current, what is voltage, what is a charge. These basic things you know. Now we are going to start with basic laws. So during this lecture we are going to talk about Ohm's law, a little bit about resistance, networks, Kirchhoff's laws, dependent sources, series and parallel, and transformations. These are all the things we are going to talk about in this lecture. So let's start with Ohm's law. First thing, basic laws of electric circuits. These basic laws are given by two scientists. First is George Simon Ohm. George Simon Ohm was a German scientist. He gave Ohm's law. What is Ohm's law? Ohm's law states that ability of any material to resist current, it is known as resistance. Suppose we have a conductor, we have a conducting wire. This conducting wire have free electrons filled in it. Now, whenever a potential difference is applied across this conductor, these electrons move toward the positive terminal because of repelling force from negative terminal and attracting force from positive terminal. Now when these electrons move in this direction, this constitutes current. Now when these electrons move, there is a hindrance in path of these electrons, which is collision with these walls and collision with other electrons. These electrons collide with other walls and within themselves, and hence it affects the smooth flow of these electrons. This resistance, this hindrance in path of current, this is known as resistance. Now this resistance is a property of a conductor. That is, the resistance depends upon the length of conductor. It is directly proportional to length of conductor. That is, the longer the length of the wire, higher will be the resistance, and this resistance is inversely proportional to area of cross section. That is, for a thin conductor, for a thin wire, resistance will be more, and for a thick wire, resistance will be less. So now when we combine these two and apply constant of proportionality, we get R is equal to rho L by A. Now here this constant rho, it is known as resistivity. Unit of resistivity is ohm meter. Now what Ohm's law states is, Ohm's law states that for any conductor we have some voltage across this conductor and we have current flowing in this conductor. So this V is directly proportional to I. This is Ohm's law. That is, voltage across this conductor is directly proportional to current flowing inside this conductor. And when we simplify this proportionality, we get V is equal to Ri, where R is resistance. This is simply Ohm's law. Ohm's law states that this is the symbol of a resistance. In simple word, Ohm's law states that voltage across a resistor is directly proportional to current flowing through resistor, which leads to V equal to IR. Right? Now, if we talk about R, resistance is equal to V divided by I. Therefore, unit of resistance is volt per ampere, or we know it as ohm, and represented with symbol omega. Okay, so this is Ohm's law. Moving further, now there can be two extreme cases for a resistance. Now, if we discuss extreme cases, there can be two extreme cases for resistance. One is resistance is equal to 0. Second is resistance is equal to infinity. Let's discuss about resistance is equal to 0. So, when resistance is equal to 0, then it is known as short circuit. Resistance is 0 resistance means just a connection of wire. So suppose this is our network or circuit. 0 resistance between terminal A and B means just connecting these two terminals by a wire. This means a short circuit. Short circuit means 0 resistance. Now, from Ohm's law, we know V is equal to IR. So if R is equal to 0, then V is equal to 0. That means across a short wire, there is no voltage difference. So voltage at point A, that is VA, will be equal to voltage at point B. So VA will be equal to VB. So voltage will be 0, but there will be some current which we don't know yet. We can find it out by applying other laws, but we don't know yet. So across a short wire, resistance is 0, voltage is 0, current is there, but we don't know yet. Now, talking about R is equal to infinity, it is known as open circuit. Open circuit means, if this is our network, open circuit between these terminals means simply there is no connection between A and B. This means R is equal to infinity. What is the meaning of infinite resistances? There is so much resistance that there can be no current between these two terminals. So in an open circuit, resistance is infinity, current is 0, and there will be some voltage which we can find out by applying other laws. So resistance 0 means short circuit, resistance infinity means open circuit. Now, talking about resistance, resistors, this is the symbol of a resistance, what we call as a resistor. Any material which obstruct the flow of current is known as a resistor. Now, resistors can be of two types: fixed resistor or variable resistor. Fixed resistors, the value of these resistors are fixed, and variable resistors, we can change the value of these resistors. So these are like this long resistors, and there is this connector. We can move this connector to different places to change the value of resistor. Now, resistors behave differently at low frequencies and at high frequencies. At low frequency, a resistor is simply a resistor, but at high frequencies there is some leakage reactance as well as leakage capacitance included in resistor itself. So this is the resistor at high frequency, this is a resistor at low frequency. Now, to remove effect of this leakage reactance or leakage capacitance, there are two special types of windings which can be done, which is known as Ayrton-Parry, and second is bifilar winding. We will discuss these later in the chapter of resistance. Moving further, now we know ability to obstruct current is known as resistance. Now discussing about conductance. Conductance is just opposite of resistance, that is G is equal to 1 by R, I by V. Conductance is how easily current flows in a conductor. So any resistance can be expressed in terms of conductance. Suppose a resistance is of 10 ohm, so we simply invert this resistance, we will get conductance. Unit of conductance is Siemens, denoted by symbol S. So if resistance is 10 ohm, then conductance is 0.1 Siemens.